So this is lesson 4.2. This is going to talk about log functions and their graphs. We've already explored exponentials a little bit. We're going to talk about some logs today. We want to be able to identify some of the key features of log graphs. We're going to talk about how they're different from exponential and what they look like. And sorry, this should say a log graph. We're going to talk about the transformations, and we're going to write the equations for them as well, okay? A log is the inverse of an exponential function. And inverses means that they are reflected across that identity line that we've talked about. And the domain and the range are switched. So we've talked about before that the domain of an exponential is all reals. Is all reals except for wherever there are asymptotes. Well, now the range is going to be all reals, and then the domain is going to be restricted on a log, okay? Looking at some key features, similar to exponentials, there's an asymptote. This time it's a vertical one. So an exponential has a horizontal asymptote. A logarithm has a vertical asymptote. Instead of going through the point 0, 1 like an exponential does, a log goes through 1, 0. And then instead of being through 1b like an exponential would be, it goes through B1, okay? We again have the inverse of like a growth and a decay, and those are flipped around a little bit. So this one would be if the base is greater than 1, that would be the inverse of a growth. And then this would be if the base is less than 1, but still greater than 0, that would be the inverse of a decay, okay? Let's look at this one here. We've got y equals log base 2 of x. Let's talk about the domain for a second. Notice that the domain is restricted. There's an asymptote at x equals 0, and then it goes to the right of that. So the domain is going to be 0 to positive infinity. The range is going to be all reals, or we can also say negative infinity to positive infinity. Again, I don't really care which one you use. I'm fine with either of those. They both make sense. Okay. The end behavior that we want to talk about is what's happening as we're leaving the graph to the right. So as x approaches positive infinity, what's happening to that graph? It's going to keep going up. F of x is going to approach positive infinity. And then what's happening as x approaches negative infinity? Well, it doesn't, okay? This time x is approaching 0. And remember, we want to designate that that's from the right side. And then f of x is going down, which means that f of x is approaching negative infinity. So this is a little different than kind of what we've done before. It goes back to when we were talking about rationals and we were writing that limit behavior. It's kind of a combination of that as well as end behavior. When we transform a log function, we use this form. Remember, C and D are interchangeable with H and K. They still all have the same functions, okay? We've got A, we've got B for the base. We've got C or H, and we've got D or K. A vertical shift is D, or again, we could use K. Either one is fine. Moves the graph up or moves the graph down. The asymptote stays the same. So this is a little different than exponential, but the points would be different, okay? They would be moving up or down. This one is a little more difficult to see, I think. You have to be kind of careful about figuring that out because you can't relate to the asymptote, okay? A horizontal shift is a little bit easier because you can see that the asymptote moves, okay? So when it moves left, the asymptote moves left. When it moves right, the asymptote moves right, and it's a little bit easier to see that, etc., okay? We can also have a stretch or a shrink. A vertical stretch would be if A is a number greater than 1, and a shrink would be if A is less than 1. So for example, we might have something like g of x equals 2 log b of x. Or we might have h of x equals 1/2 log b of x, okay? So notice that a changing is what shrinks or stretches the graph. I should also note, sorry, let me go back here, that negative flips, okay? And that'll be a vertical flip. So when a is negative, we have a vertical flip. So let's look at some equations here, okay? So we've got an equation here, log base 3 of x minus 2. We want to know how this is moved. Well, first of all, I can see that the asymptote is still 0. So there is no horizontal shift here. Actually, that's not true. There is a horizontal shift of 2 because this is an H. Whoops. This would be shifting right 2. Unfortunately, the equation doesn't match the graph, and I don't know why. Oh, maybe because I can't read. This is the parent graph. Hey guys, reading is super important. And so this is a shift of that. So it would be shifted 2 to the right. So our new asymptote would be here, and then our graph would be something like this. I'm going to draw it very poorly. Sorry. There we go. Okay. So this is shifted to the right 2, which means that the domain is now from 2 to infinity. The range is still all reals, or negative infinity to positive infinity, okay? That doesn't change. The asymptote this time is at x equals 2 instead of x equals 0, and the x-intercept is at 3, 0, okay? Let's look at another one. Here's our equation. It again has shifted. This time, because the minus 2 is outside, this is a shift of down 2. By the way, this word describe means use words to tell what's happening. It's a throwback to your test. Some of you wrote an equation, which is awesome, but the word describe means tell us in words what's happening, okay? So this would be moving down 2. So it would look something like this. However, that asymptote is still at x equals 0. That doesn't change. Remember, it only changes if there is a horizontal shift. In this case, it's vertical, okay? So the range also still negative infinity to positive infinity, and the domain is still 0 to infinity. The x-intercept is the only thing that has changed. And we can't see that on our graph, so we would have to kind of figure that out from the equation, okay? Which could be a lot of fun. Remember to find the x-intercept, that's when y equals 0. So we could say 0 equals log base 3 of x minus 2, add 2. And then from there, I don't know if you guys remember this, but we solved exponential equations last year, which means that the x-intercept is at 9, 0. That was kind of a fun little exercise in solving some exponential equations to find the x-intercept. This one we're multiplying by 2, which means that we have a stretch. Okay, so the asymptote is still the same, x equals 0. The range is still the same, negative infinity to positive infinity. The domain is still the same, 0 to positive infinity. But everything's going to stretch by 2. So we're going to have here, and let me get this right here. Something along those lines. So again, don't judge my graphing. The x-intercept, instead of being at 1, 0, is now at 2, 0. Okay. That is it for this. Again, just some few basic things that you need to know. Domain and range are very important. Make sure that you understand they are sort of, well, they're the inverse. They're flipped from exponential. Also know the asymptote and how that moves, as well as being able to find the x-intercept. Most of the time you'll be able to see it on the graph. Okay, we're going to use Desmos for the most part. And you'll be able to see where that x-intercept is. I try, and I'm air quoting, you can't see me, I'm air quoting try, because I try to make them nice. It doesn't always happen, unfortunately, but I do my very best, okay? Go ahead and work on your assignment, and I will see you tomorrow.